Section 4.6. This is about graphing with calculus and calculator. So in the previous section we looked at how to sketch a graph by hand using calculus tools such as derivatives, concavity, things like that. So here we're gonna see how, probably you want to say, how can I check my graph on the calculator? So you graphed it in the previous section, and now we need to see how to use the graph to check if our graph that we did by hand is correct. So we're going to show you on the TI-84 Plus. It works the same on the TI-84, the standard one, TI-83, 83 Plus. All the calculus that we usually use, they work in a similar way. So we're going to see how to graph. Let's look at our function. The first function we graphed in the previous section, it was this one, y equals x squared over x minus 1. So how do we insert this in a graphing calculator? We always go to the key on the upper left corner, which is y equals. And there's nothing there. If there's anything there, you click on the key that says clear. The one that says clear here in the first column on the right side. That will clear up everything. How are we going to put x squared? So the x is right above APPS, so that's an x. If you want to put a square on the left column, in the middle of it, there's a square there. Or you can use this one here that looks like upside down V in the first column. On the right side, above the division sign. So I'm going to do x squared, and then the division, I'm going to divide. See that quantity under the in the denominator x minus 1, we must open a parentheses for that, and then put x minus 1 and close the parentheses. Otherwise, the calculator will take the minus 1 and put it next to the fraction. It's not going to understand that this whole amount or quantity, x minus 1, goes all in the denominator. So we have to place a parentheses around it, so to make sure the calculator understands that this entire quantity goes in the denominator. And then we click on the graph in the upper right corner. So it's gonna graph it for us. One thing, if you compare this and the one we got, the only thing missing here is the vertical asymptote. These calculators don't show vertical asymptotes for us. Just keep that in mind. It will show the two branches but not the vertical asymptotes. So that was the first one we graphed in the previous section. We did graph also y equals x over the square root of x squared minus, actually this x squared minus 1, there was no radical first. X squared minus 1. So let's graph this. Go again to y equals, clear this up, and I'm going to do x divided by, again open parentheses, x squared minus 1, and then we're going to graph it. So the graph, looks exactly the one we got. Is a good way of testing it. If we need to look at a different graph, let's say x squared plus 5x plus 3 all divided by x squared. How do we graph this? Go to the same screen or window, clear everything up. I'm gonna put a parentheses around this quantity. So parentheses x squared plus 5x plus 3 divided by x squared. So x squared like that. So now we graph it. When you graph it, that's what the graph is. Two branches like so. It doesn't show us as x equals 0 vertical asymptote, but it is. If I want to graph a different function, let's say y equals x squared minus 1 e to arc sine x. Arc sine means sine inverse. So let's go again, y equals, clear this up, open parentheses, x squared minus 1, and we have the exponential part. I need exponential. It's in the first column where it says ln in blue. So to access that, we have to click second and then ln. And that will be ready to enter the arc sine. Arc sine is exactly where the sine is, with just the it's in blue, so you have to use the second for that. And then it's asking what do you want here is x, close it, and then graph it. Now when you try to graph it, look how the graph looks like. One thing you have to be careful about when you do the graphing trigonometric functions, we need to make sure the mode is radians. So this one, you can, if you like to see it, you can click on zoom and zoom in, zoom out, as you can see. We have several things here good to know. Usually if I click on the window first, it says between negative, the x value -6 to 6. That means it's going to go from the window like this, and the y is -10 to 10. The standard window is always between -10 to 10 on the x, -10 to 10 on the y's. But what this did, the graphing calculator kind of like changed in the window scales or bounds to make it fit to the on the window that we have for this function. So in the zoom option, if you go down to number 6, it says Z standard. Z standard, it will change the window down back to -10 to 10, -10 to 10. If you do Z trig, it will kind of take a trigonometric function and zoom fit it into this window. We have another one that I use a lot. It's called zoom fit. It's going to take no matter what function you have, and it's going to fit the graph of it within this window that we have. It changes the bounds of the window automatically and fits it in there. That's a good thing to do. You can change these if you like. Make sure when you use the negative sign is the one below number 3 on the keyboard here on the calculator, not the -1 on the right side. Same thing happened in here in the y min. It should be -10, not -10. So the graph of the function, back to this one, this is the mode. Next to second, there's a mode. If you click on the mode, you go down to the third one, is blinking on the radian mode. Make sure it's radian, not degrees. That's degrees, but you can use the arrows to go there and make sure to hit the enter key means it's radian. Second mode to quit, and then you can go back to y equals this. Again, the graph will look like something like this. You can zoom in and zoom out for this one. Now, before I forget, make sure another tool that I personally use when I have access to the computer is Desmos. Desmos is more powerful than this. You can zoom way more in and out to see the figures. It gives you even like what is the lowest point. If you hover the cursor around it, it gives you intersecting points. It gives you the lowest point the graph could reach. I would strongly encourage you to use Desmos as well. It's very powerful software. What about other functions? Can we look at graphing y equals x to the 6 minus x to the 5th plus 3x to the 3rd minus x squared plus 2x plus 5. So how do we graph a function like this? So we can go y equals, clear this up, and then we're going to go x, raise it. This is the one right above the division sign to the 6th power. Use the arrow to go down to this way, you see, to be on the same line, minus x, raise it to the 5th power, go down to next to it, 3x, raise it, actually wait, delete this, delete it. It's a plus, we forgot to put the plus, 3x, raise it to the 3rd power, and then down to minus x, raise it to the 2nd power. Again, down, plus 2x, and plus 5, and graph it. So the graph might appear like this. Do you see? Again, as I said, you can zoom in and zoom out. So if you go zoom in, hit the enter key twice. See, it might cut it off there. So if you do zoom again, zoom out, it's gonna return it back as it gave us earlier. And then if you do it again, zoom out twice, it's gonna look like really so tiny. So what about if we go zoom and zoom fit, just so you see it? Zoom stat, zoom fit. See, it's gonna take it and really fit it in the graph, in the screen we want it to have. So that's how we use calculator. Now, possibly one more thing I can show you here is how you graph log x base 5. To do so, let me go here and clean everything up. If you go to math and then scroll down to log base, hit the enter key, it gives you base 5 and then x, and then hit the graph. Now the graph, before I had it this window, so what are you going to do? We're going to go zoom and then z standard. So that's the graph of the y equals log x base 5. Any function you like to enter in, you can do it, like the calculator will graph it for you. Even the last one we graphed x over the square root of x squared minus 1, you can do that as well. Any function you want, you can always find it here on this calculator, and it will graph it for you. But again, you can always use Desmos to sketch a graph for any function you want. Desmos is very powerful, very powerful.